The next feature I need to tackle to build this model is the fluorescent bulb. The bulb is created with a single sweep of a simple circle for the profile and a complex 3D sketch spline in 5 sections used as the path. If we take a closer look at the path, it's made up of splines made in 3 different ways: intersection curve, spline on surface, and freehand splines. First, I'll tackle the intersection curves because it defines the shape of the bulb, and the spline on surface and freehand 3D splines are really just blending between the ends of the intersection curves in the fluorescent tube ports. So, how do we create the intersection curve? It appears to be a pretty complex curve in 3D space, and there's no single SOLIDWORKS command that can create this shape. Well, first notice, the fluorescent tube is shaped in such a way as to remind you of the shape of a conventional light bulb, with a tube wrapped around it in a helical shape. So to create the intersection curve, I start by creating both shapes, the helix and the conventional light bulb, and then finding the curve where they intersect. Now the light bulb shape is easy. I draw a spline on the right plane, making sure that where the spline touches the center line, there's a horizontal constraint on the spline handle so that the top of the bulb is smooth, not pointed or indented. Remember that a solid revolve cannot touch the center line at a point because that would cause a point of 0 thickness, but a surface revolve can touch at a single point. Revolving the sketch 360 degrees as a surface creates the light bulb shape we need. Next, I need to create a helical surface to intersect with the revolved surface. Where they intersect is where the fluorescent tube sweep path comes from. As a hint, I often turn surface features slightly transparent to help me distinguish surface bodies from solid bodies visually. I'll start by offsetting a new sketch plane from the top plane. The location of this new plane will be the bottom of the intersection curve, which I'm just setting visually. Maybe about 2.5 inches from the top plane. I'll name this plane Twist Plane. Next, on the front or right plane, I'll sketch a vertical line from the twist plane. This line will be the path for the helical surface sweep, so it needs to extend enough to come near the top of the light bulb surface. Now, sketching on the twist plane, I sketch a line angled 45 degrees from the front plane that extends beyond the outside of the bulb surface. This line will be the sweep profile. With the profile and path created, I click the Swept Surface toolbar button and select the horizontal line as the profile and the vertical line as the path. Expanding the Options panel displays the setting we'll need to create the twist for the helical shape. In the Orientation Twist options, select Twist Along Path, Define by Turns, and assign 1.5 turns to the sweep. Using the method is faster for creating a helical sweep than actually creating a helix. Since helixes, and in fact any curve features, cannot be copied or patterned, using this method gives me another advantage. Because the fluorescent tube needs two of these semi-helical sections, I need to create two curves separated by 180 degrees. To do this, I must copy the helical surface I just created. Copying and rotating a surface body can be done in a single step using the Move Copy Bodies tool. I select Move Copy from the Insert Features drop-down menu. I'll select the swept surface body, check the Copy option, and tell it to rotate about the Y-axis by 180 degrees. To find the intersection between the swept and revolved surfaces, I next use the Intersection Curve tool on the Sketch toolbar. This tool may not be on the toolbar by default. It can also be found through the menus at Tools, Sketch Tools, Intersection Curve. When this tool is activated, without being in sketch mode, it automatically puts me into a 3D sketch. Selecting the revolved, swept, and the copied bodies causes a pair of 3D splines to be created where the surfaces intersect. Now once the intersection curves are created, I'll turn off the Intersection Curve tool and hide the sweep surfaces to see the intersection curve more clearly. Before I move on to joining the two splines, I'll make certain to delete the center line that was created as a result of the Intersection Curve command.